so yesterday we started out talking about the different polygons, what makes a polygon, and how they're named. They're named by the number of sides. So we talked about for it to be a polygon, they must have straight lines for the sides, and all sides must connect. We talked about that for it to be a regular polygon, all angles are congruent, and the length of all sides are congruent. We talked about the polyhedron, that is a three-dimensional shape. All sides are congruent. If it's a prism, the sides are always a rectangle or a square. That if it is a pyramid, the sides are always a triangle and meet at one point at the top. And one thing that we did not talk about yesterday, you need to write this down on this front page of your notes.
Do you have another pack? You have more note packets? There was two that weren't here yesterday? Or
Yes.
three?
They're on my desk. I thought I gave it to them. I'm sorry.
That's what I didn't want to.
All right. The base. The base. That's the piece that it not necessarily sits on, but it's a piece that does not have to be a rectangle, square, or triangle. The sides of pyramids and prisms will always be rectangle, square, or triangle. The base if it is a pyramid, it will have one base. Pyramid will have one base. That means one side that is not necessarily a triangle. You get the name from the shape of the base. So if it is a square with triangles around it, it would be a square pyramid. If it's a rectangle with triangles around it, it's a rectangular pyramid, and so on and so on. A prism will have two bases that are exactly the same. A prism will have two bases that are congruent. Alright. So then we went on and we talked about faces. Edges are the same as a line segment. Vertex were called a point. And then we talked about Euler. And his theorem that says faces plus vertex minus 2 will give you the number of edges. Alright. So look at example number 2 in your notes. Example number 2 from your notes. All right, example number 2. All right. Find the number of faces, vertices, and edges of the polyhedron. Check your answer using Euler's theorem. Alright, so first thing we're going to do is count the number of edges. And I'm going to tell you why I think edges are the easiest to count. Because you can see them very clearly. The edges will either be these dotted lines or these solid lines. Okay, so let's count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So edges equals 9. To me, that's the easiest one to count. Because it will either be the dotted line or a solid line. So that's all you're doing is counting how many dotted lines and solid lines. So edges was 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Now, the next thing I think it's easy to count is your points, your vertices. How many vertex you have? Because you can see them. There's one right there, one there, one there, one there, and one there. So it's right where those lines come together to make a point. That's your vertex. So how many vertices do we have? 6. Good. Now, from this point, I'm just going to use Euler's theorem and plug it in and solve a problem. Alright, so what did Euler's theorem say again? Alright, don't yell out. This time I want what? Yeah, I took it from the sheet. Alright, so let's see. Micah, what did Euler's theorem say? Faces plus vertices minus 2 equals edges. Good. So if you don't have that on your notes, you need to write that down. Faces plus vertices minus 2 equals edges. All right. Faces plus vertices minus 2 equals edges. So we have 2 pieces, so we can set up an equation. So we need faces plus, we have vertices, we have minus 2 equals edges. Now, so all I have is a 1-step a problem at this point. Can I go 6 minus 2? All right, wait a minute. Miss Allen, can I go 6 minus 2? If you have 6, can you take away 2? Yes. So what is 6 minus 2? Oh, Miss Allen? What is 6 minus 2? So F plus 4 equals 9. Alright. Mr. Dye, what am I going to do now? Okay, hold on, I couldn't quite understand you. Say it real clear. Subtract 4 from both sides of my equation. I agree. So how many faces does this shape have? 5. Good. Alright. So let's get down here to this 1, 2, 3, 4 pentagonal prism. Pyramid. The pentagonal pyramid. So first thing let's count is our vertices. Points. How many points we have? 2, 3, 4, 5, 6. Did that get them all? Alright, so V equals 6. Now let's count how many line segments we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my line segments, which is my edges, is 10. Alright. And we set up a problem and solve for how many faces? Yes. Because we know F, which is faces, plus vertices minus 2 equals edges. So my F plus 6 minus 2 equals 10. All right, Gumby. What's the first thing I'm going to go? What's the first thing I'm going to do? Subtract what, sir? Very good. So 6 minus 2 is 4. So F plus 4 equals 10. All right. Miss Hollifield, what will I do next? Subtract 4 from both sides of my equation. I agree. So I subtract 4. So F equals 6. All right, good. So that's using Euler's theorem when you have to count your pieces. It's done exactly the same as when it gives you. All right. Okay, let's move on. Very good. All right. Platonic solids. you have to know that there are 5 of them. What makes them special is that every side is congruent. Every face is the exact same size. They all have the same angles. So really that's all you have to know is there are 5 special solids that are called platonic solids. All the shapes on each. So a tetrahedron, what do we also call the tetrahedron? Cube. Oops, no. This one would be, the bottom is a triangle. The tetrahedron has 4 faces. I pointed at the wrong one, didn't I? So 4 faces. The bottom is a triangle. The sides are triangles. So it could also be called a triangular pyramid. But what makes it a special one is that all 4 faces, all 4 triangles are exactly the same. Okay. Alright, so here's what we're starting to do today. This is called cross section. To me, this is hard because I do not visualize things in 3 dimensions well. So it may be something that's easy for you to see, but hard for others to see because some people they cannot visualize 3 dimensions in their head. All right. So if I have this shape, here's the easiest way. If it is cut a cross section that is parallel to your bases, if it's parallel to the base, the cross section will be the same as the base. All right, so if it's parallel to the base, alright, so if you take a cross section of a 3-dimensional shape, and you take that shape and you cut it parallel to the base, it will be the same shape as the base. So that would be this cylinder right here. It's been cut. They've taken a plane and they've stuck it in there and cut it. And this piece right here is the same shape as the top and the bottom, the bases. So if you cut it parallel, it's the exact same shape as your base. Now, this is where it gets a little more difficult. If you cut it perpendicular, you take where your plane has cut, and you do a dot to dot, right where it cuts it. So it cuts it here, here, and you connect right where it cut. So you have to make like a dot to dot, just a piece that was cut out. So what shape is formed when you cut a cylinder perpendicular to the base? Hold on, don't talk. Think. This is cut perpendicular to the base. Because the base and this plane makes a 90-degree angle. So what shape was made when I cut the cylinder perpendicular to the base? I'm gonna call it somebody. All right, Terrence, go ahead. A rectangle? Good. Because when you connect the corners, it makes a rectangle. So perpendicular to the base, connect the dots, the vertices, the points, where the plane crosses the solid. And that gives you the shape of a perpendicular cross section. Connect the points where the plane crosses the solid. All right. Alright, so let's look at this problem A. Parallel or perpendicular? Freddie, is this plane here in figure A, is it crossing this picture parallel or perpendicular? So right here. Parallel, I agree. So it's crossing it parallel. So look back at your notes. Parallel tells you the cross section is going to be the same as the bases. So what shape is the cross section in A? Mr. Richardson. In shape A, what shape is the cross section? Square. Good. Because it is going parallel, it's the same shape as the bases. Now, I said when it was perpendicular. It also, you connect the shapes that connect the dots when it's going in a shape that's not perpendicular. So anytime it goes across, that's not parallel. You connect the dots where the plane touches the shape. At a slant, at anything other than parallel. Alright, so this one on B, we touch here, and here, here, and here. So when you connect those dots, what shape was made? Kadasia. What shape is made? Well, if you can't see it, come up here close. Don't. That's okay. Shh, quiet. Shh. You connect here. They cross right there. Right there. There. And there. So it crosses, they connect in 4 places, so it has to be 4-sided figure. Rectangle, I agree. Alright. So C. They cross here, 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 and here. Mr. Dye, what shape is made in C? A trapezoid, I agree. Alright. Your assignment tonight. Alright. I'm waiting. $25 through $25 through 32. 25 to 32 on page 799. All right. 25, 26, and 27. Draw and describe the cross section formed by the intersection of the plane and the solid. So first thing, you have to draw the shape that was made. Not the whole 3-dimensional shape, the shape that was made when you made the cross section. You have to draw that shape. Alright, 28. Shh. Number 28. You'll have to draw the picture out. It says it's formed by a plane that is parallel to the base. If it's parallel, what do we know it's going to be? Hold on. If I'm cutting my plane horizontally or parallel to the base, parallel. Go back in your notes and look what it means when I say I cut it parallel. Means it'll be the same shape as the base. Good job, Jade. Alright.
page number do we have to do?
You're just working on this page 799. You're doing problems 25 through 32. 25 through 32. All right. All right, if you do not have access to a computer or internet, once you leave school, I'm putting it up here. You can take a picture of it with your phone. There's no reasons whatsoever to not be able to do your assignment. You have time in class right now.
Can they screenshot it on their computer?
You can screenshot it on your computer. Screenshot is Control Shift and the button above the 6. You can screenshot it and that will also come up. Alright. Guys, I'm not playing about homework assignments and them not being done. Alright, so we better get on the ball.